Week 10, Statistical Methods for Outlier Detection. Welcome to our Beginner's Guide to Statistical Outlier Detection in Python. In this lesson, you will see how to spot strange data points using statistics. We will start by loading a real credit card fraud dataset, explore what outliers are, and try several detection methods with hands-on code. Let us get started and remember, outlier detection helps us find fraud, errors, and rare events in all kinds of real data. Running the cell now. What are outliers? Outliers are data points that look very different from most others. They might be errors or special cases. Why care? In credit card fraud detection, outliers often point to suspicious transactions. Today you will learn to find outliers using both simple and advanced statistics. Running the cell now. Let us get our data ready first. This code sets up the credit card fraud dataset, which is real transaction data. We suppress all warnings to save space and focus. We use pandas to work with data tables. Import numpy as np. We set the random seed to 42 for reproducibility. We fetch the dataset directly from a public Google Drive URL. We load it as a data frame, which is a table of values. We see how many rows and columns it has. The first 3 rows give a quick idea of what is inside. Running the cell now. The output shows our dataset has 284,807 transactions with 31 columns, including anonymized features, V1 of V28, transaction amount, time, and the class label indicating fraud, 1, or normal, 0. Noticing the shape and column structure here is key for understanding how outliers, potential fraud cases, are embedded within a large, high-dimensional dataset. Practice, see if you can find how many columns are in this data. Try changing head 3 to head 10 to see more rows. Now let us explore what is in our dataset. This is a comment stating that we're about to get a quick overview of the data. We print out all column names in the data frame to understand what features we have. We display summary statistics like mean, STD, minute, max for each column to get a quick sense of the data distribution. Running the cell now. This output gives a snapshot of the dataset structure and key statistics, showing columns like time, multiple anonymized features, V1 to V28, amount, and the target class. Notice the wide ranges and extreme values in columns such as a V2 and a V4, hinting at potential outliers, which is critical as we explore unusual transactions that might indicate fraud. This initial summary helps us identify where outliers could exist and guides our next steps in detecting and handling them. Practice, do any column names look unusual? Which columns might be good for checking outliers? What should we check for outliers? Outliers are most interesting in columns with numbers, such as amount, time, or features named V1, V2, and so on. We will focus on the amount column, as it shows the value of each credit card purchase. Running the cell now. Let us see how credit card amounts are spread out using a histogram. We use matplotlib to plot data. We make a wider plot for better visibility. We draw a histogram of the amount column, breaking values into 50 groups. The bar color is teal, with black outlines for contrast. We add a title for context. We label the x-axis to show we are looking at amounts. The y-axis shows how often each range happens. This final line makes the plot appear. Running the cell now. Here, the histogram of the amount column reveals the distribution of transaction values, showing most purchases cluster at lower amounts with a few extremely high values. Notice how the long tail on the right suggests potential outliers that could impact our analysis. This visualization helps us understand which transactions deviate significantly from the norm and deserve closer inspection. Practice, can you spot any amounts that are much larger than most others in the plot? Outlier detection with the Z-score. One way to spot outliers is to check how many standard deviations a number is from the average. This is called a z-score. If a value's z-score is above 3, it is often an outlier. Let us code this. Running the cell now. We will now use the z-score to find outliers. First, we find the average value for the amount column. We also find the standard deviation, which tells us how spread out the amounts are. We create a new column for z-scores, measuring how far each value is from the average. Any value with a z-score above 3 or below -3 is seen as an outlier. We pick out just those rows and call them outliers. Finally, we count how many outliers we found using the rule. Running the cell now. This output tells us there are 4,076 transactions where the amount is more than 3 standard deviations from the mean, indicating potential outliers. Notice how the code calculates the z-score for each amount to quantify how extreme each value is. This highlights the effectiveness of z-score in spotting unusually large or small values in the dataset. Try changing the threshold from 3 to 2 and see how the count changes. Let us see the first few outliers the code found. This code prints the amount and z-score for the first few detected outliers. You can scroll through to see how unusual their values are. Running the cell now. Here, we see a preview of detected outliers based on their z-scores, where each amount is more than 3 standard deviations from the mean. Notice the very high z-scores, especially the last one at nearly 15, clearly indicating extreme values. This output confirms that our z-score method effectively flags unusually large transaction amounts as outliers. Are these outlier amounts much higher or much lower than most? Using the IQR, interquartile range, a method. Another popular approach uses the IQR, which looks at the middle 50% of data. Amounts much higher than this range can be marked as outliers. Running the cell now. Let us now use the IQR method to find unusual amounts. We perform IQR outlier detection on the amount column. Calculate the 25th percentile, Q1, of the amount data. Calculate the 75th percentile, Q3, of the amount data. Compute the interquartile range, IQR, as the difference between Q3 and Q1. Determine the lower bound for outliers as Q1 minus 1.5 times the IQR. Determine the upper bound for outliers as Q3 plus 1.5 times the IQR. Select rows where amount is below the lower bound or above the upper bound as outliers. Print the number of outliers detected using the IQR method. Running the cell now. This output shows that 31,904 transactions fall outside the typical spending range defined by the IQR method, highlighting them as potential outliers. By focusing on values well beyond the middle 50% of amount data, this code effectively identifies unusually high or low amounts, which is crucial for detecting anomalies in the dataset. Are there many more outliers with IQR than with z-score? Try comparing them. Let us peek at some of the outlier amounts from the IQR method. This shows a list of the first few outlier amounts found by the IQR test. These values are well outside the main range of transaction amounts. Running the cell now. Here, the output shows the first 5 transactions identified as outliers based on the IQR method, with amount values significantly higher than the typical middle 50% range. Notice these amounts are well above the common spend, highlighting how the IQR filters unusually large values. This confirms the method's effectiveness in pinpointing potential outliers for further analysis. Do you see any extremely high or low amounts that stand out? Outlier detection using box plots. A box plot is a simple way to visualize outliers. Outliers show up as points far from the box part of the plot. Let us use one to see amount outliers quickly. Running the cell now. Let us make a box plot to spot outliers visually. We set up a wide, short box plot for clarity. The plot shows the spread of all transaction amounts, with outliers as dots. We pick a pleasant background color for easy viewing. The x-axis shows transaction amounts. The plot title explains what we are looking at. The plot window opens to show us the result. Running the cell now. The box plot displays the distribution of transaction amounts horizontally, highlighting the central 50% range in the blue box. Notice any points plotted far to the right, which indicate potential high-value outliers. This visualization helps quickly identify unusual transactions that may need further investigation. Can you find any points that look far away from the main box? Multivariate outlier detection, Mahalanobis distance. Sometimes outliers do not stand out in a single column, but in combination across several columns. The Mahalanobis distance is a way to measure how far away a row is from the center, taking into account many features at once. Let us try this on a few columns together. Running the cell now. We will now look for outliers considering several columns at once. We use Mahalanobis distance, which works well with numeric columns. We import NumPy for numerical operations. We import the chi-squared distribution from scipy.stats for thresholding. We select the columns v1, v2, and amount to analyze. We extract the values of these columns into a NumPy array. We calculate the mean vector across all rows for these columns. We compute the covariance matrix of these features. We calculate the inverse of the covariance matrix for Mahalanobis distance. We find the difference between each data point and the mean vector. We calculate the Mahalanobis distance for each row. We determine the threshold based on the chi-squared distribution for outlier detection. We select rows where the Mahalanobis distance exceeds the threshold as outliers. We print the number of detected Mahalanobis distance outliers. Running the cell now. Here, the code calculates the Mahalanobis distance using three features, v1, v2, and amount, to identify points far from the multivariate center, beyond a 99.7% confidence threshold. Notably, it detects 8,084 outliers, highlighting how considering multiple columns together uncovers many anomalous rows that might not appear unusual when examined separately. This shows the power of Mahalanobis distance for multivariate outlier detection in practice. Try changing which features you include in calls to see how results change. Let us look at some of these multivariate outliers. We display the first few detected outliers using Mahalanobis distance. Notice how these rows might look normal in one column but strange when used together. Running the cell now. Here we see the first few detected multivariate outliers based on their Mahalanobis distance scores, z_score, across columns v1, v2, and amount. Notice how some rows with extreme combinations of features, like row 51 with very high amount and large negative v1 and v2 values, have high z_scores indicating they are far from the data center. This highlights how Mahalanobis distance captures outliers that may not be obvious looking at any single column alone. How do these unusual rows compare to the single column cases from before? Mini-project, outlier removal and model training. For our mini-project, we will build a simple classifier to tell fraud from normal. First, let us remove the most extreme outliers, then train a logistic regression model. Let us see if cleaning data first helps our results. Running the cell now. Let us remove the most extreme outliers and prepare our data for modeling. We filter out rows with z-scores above plus or minus 3 to remove unusual cases. We use train_test_split to divide our clean data into training and testing sets. We drop columns not useful in training, like class and time and z_score. Class is our label, 0 is normal, 1 is fraud. 70% is used for training, and 30% for testing. We make sure the split is the same every time with random_state equals 42. We print how many rows are in each group. Running the cell now. After removing extreme outliers with a z-score cutoff of 3, the dataset reduced to about 280,000 rows, which were then split into training and test sets. Notice how the training set contains roughly 70% of the data, 196,511 rows, and the test set about 30%, 84,220 rows, ensuring a balanced split for reliable model evaluation. This step is crucial as it prepares clean, representative data for training our fraud detection model. Try changing the test underscore size to 0.4 or 0.2 and see how the split changes. Let us train a model and test its accuracy after removing outliers. We start by describing the task, training a classifier and scoring it. We import logistic regression, which is a simple but powerful model for yes or no classification tasks. We import accuracy score to measure how well our model performs. We create a logistic regression model with a maximum of 200 iterations and set a random seed for reproducibility. We train the model using our training data. We ask the model to predict fraud or not on the test set. We calculate how often the model is correct, which is called accuracy. We print the accuracy as a score between 0 and 1 after removing outliers. Running the cell now. The output shows a model accuracy of 0.999, indicating nearly perfect classification on the test set after removing extreme outliers. This high accuracy highlights how outlier removal can significantly improve model performance by focusing the classifier on more representative data. Notice that this step sets a strong foundation before moving on to more complex model tuning or evaluation. Try repeating this step using the full data with outliers and compare the scores. Which is better? Review and best practices for outlier detection. Outliers can hurt models and hide patterns. Always visualize and explore before removing data. Try multiple methods, z-score, IQR, and multivariate distance. For big data, consider using automated tools in Pandas or Sklern. Remember, outlier removal is an art, not a strict rule. Running the cell now. Challenge exercise. Try finding outliers in a different column or with a different cutoff. How does changing the threshold affect your results? Bonus, try plotting transactions with and without outliers. Running the cell now. Recap. You learned what outliers are and why they matter. You tried z-score, IQR, and Mahalanobis distance. You saw how outlier removal can make fraud detection models better. Keep practicing with other datasets and try outlier detection anytime your data looks a little strange. Running the cell now. Thanks for following along. Did you enjoy learning about outlier detection? Do not forget to subscribe and hit the bell to catch our next lessons on data mining and AI. What topic should we cover next? Comment below. Running the cell now. Practice, write down one thing you learned or a question you have in the comments. Subscribe if you found this useful.